50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
That we would discover life-saving,
Earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go. "50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
that we would discover life-saving,
Earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go. "50 years ago, we went to the moon. We called it Apollo.
What many people don't know is that Apollo had a twin.
She was a woman named Artemis,
goddess of the moon.
We are returning to the moon
as a new generation of explorers.
This time to stay.
And to prepare to achieve humanity's next giant leap of sending the first human missions to Mars.
We believe our course will redefine what is possible.
that we would discover life-saving,
Earth-changing science.
And that the challenges ahead will inspire generations.
This is our manifest.
For all who wondered if we could return.
For all who dreamed of pressing beyond.
This is your calling.
We go for all of America.
We go.
We go as the Artemis generation.
We go.
Hi everybody, my name is Patricia Moore and I'm sorry for the difficulties this morning, but we think we've got it all worked out. I really appreciate your patience and I'm super excited to be able to talk with you this morning about NASA's Artemis program. And so earlier we had the video replaying as we were trying to work out some issues, but again, thank you for your patience and I'm excited to get to talk with you today. All right. So let's go ahead and get started discussing NASA's Artemis program. All right, so I work at Johnson Space Center, which is home to astronaut training and mission control, and the Artemis program is our new human lunar exploration program. And so here at Johnson Space Center in Houston, Texas, part of our job is to get the astronauts prepared. We also work with all the different groups that are building the spacecrafts and rockets, and we have teams all over the country and 10 different NASA centers, as well as thousands of suppliers, so different companies that are all working to make our vehicles and our spacecrafts and get our astronauts ready to fly for the Artemis missions. So NASA Artemis program is like I said, our new lunar exploration program, and we are set to send the first woman and the next man to the moon in 2024. That is our goal. And Artemis is named after the twin sister of Apollo in Greek mythology, and it's the perfect name for a new lunar program that includes both women and men. So we've got Apollo and now we have Artemis. So Artemis, we've been working really hard the last several years to get things ready, and we're almost ready to fly for our first mission in 2021. And a lot of folks will ask, well, why do we go to the moon? Why is that important? And why are we going back? And depending on who you ask, you get a different answer. So if you ask a planetary scientist, they're going to tell you all about the great things we can learn about our own planet by studying the moon, about our solar system, about our sun. And there's just a lot of really amazing things we can learn by landing in the South Pole region of the moon, which is where all of the water ice is. And if you ask our mission planners that are helping our astronauts prepare to go to the moon, they say this is a great place to test out all of our environmental control systems, our life support systems, our spacesuits, our habitats, our landers, and all the equipment we'll need for future Mars missions. So Artemis is a stepping stone to Mars, and Artemis will be the program that helps prepare our NASA engineers and scientists, as well as our astronauts, for future missions to Mars. So we are going to the South Pole area of the moon, which is in this crater particularly, Shackleton crater, is of interest. There are other craters that we're looking at, but the reason we like Shackleton crater along with other craters around the moon is there are permanently shadowed areas, which means there are parts of these craters that have never experienced sunlight, and so the water ice has never been melted. So temperatures on the moon can get really extreme. They can be very warm in the summer in sunlight, and they can be very cold when you're in the shade. And so Shackleton crater is one of the smaller ones. There's actually larger ones, and this particular crater is about the size of Washington, D.C. And you can see, if you pay attention to the craters along the South Pole, you can notice that the middle parts of the crater never get any sunlight throughout the year, but the edges of the crater get sunlight most of the year. And so that's great. We have parts of a crater that's never exposed to sunlight, but then there are other parts of the area along the crater that are almost in constant sunlight. And that's important because we depend on the sun for our electricity in space, and our habitats will run on solar power. So we need to land in a part of the moon that's almost in constant sunlight. So the South Pole is where we're headed, and eventually we'll explore other parts of the moon, but we're going to start with the South Pole. All right. So when we plan missions to go to space, we have several destinations in mind. Most of the time when we go to space, we're going to the International Space Station, and that's only 250 miles above the Earth. And in order to get to the space station, we have many different kinds of rockets. We have rockets that are designed for humans and rockets that are also designed for robots and satellites. And we've been doing this for a while, and we have lots of options when it comes to getting into space and Earth orbit. Now, when we go to the moon or in deep space, your vehicles have to change, right? You have to have a rocket that's more powerful to get cargo and spacecrafts and supplies and even astronauts away from Earth orbit. And we have rockets that have done that with smaller vehicles, like with the Opportunity rover that just launched, and even Curiosity in 2014. There are vehicles that can get robots out of Earth orbit, but we don't have a human-rated rocket or a human-rated spacecraft that can get humans out of Earth orbit into the moon or farther destinations. And so we've been building them. And you can look at this chart and just see how much more challenging our missions get the farther away we get from Earth. Now the moon is 3 days away. The Mars is 9 months away. Okay, your reentry speeds have gone from 3,000 degrees Fahrenheit to now when you come home from Mars, you're traveling so fast, your reentry speeds around the atmosphere gets even hotter, and you're much, much farther away. So the farther away you get from Earth, the more supplies you need, the more dependent your astronauts have to be, and then just the more challenging things are in general. And so that's why we have Artemis program, is so we can test out a lot of our systems. And one of the first things we had to do is we had to design and build a rocket that could get our astronauts away from Earth orbit, because we don't have a rocket that can do that in our inventory. So the Space Launch System is our deep space rocket, and it will be the most powerful rocket NASA's ever built, even more powerful than the Saturn V rocket. And the Saturn V rocket is massive, right? That's the rocket that took our astronauts to the moon during the Apollo missions. And the Saturn and the Space Launch System will actually be more powerful than the Saturn V. And so that first version of the SLS you see that says that's the first version of the rocket, that will be for our Artemis 1 launch. And it will carry, the first mission will just carry the rocket and the spacecraft with no people. And then as we get to our second and third launches, we'll have humans on it. And then our rocket can even get bigger when we're talking about going on to Mars one day. Now, the Space Launch System is almost finished. The white boosters on the side are done, and the top parts of the rocket are done. The last piece that we're testing is the core stage, which is sitting at Stennis Space Center in Mississippi right now. And it's there, and we will fire all 4 engines at the same time, strapped to a test stand this October or November. And once we've done that, we'll be able to send that last piece of the rocket to the Kennedy Space Center to get assembled and stacked with the spacecraft that the astronauts will ride in. So the Orion spacecraft is where the astronauts will sit inside and will fly, and we can fit 4 astronauts comfortably inside this spacecraft for about 21 days. And so this spacecraft is kind of like a ferry. It will ferry our astronauts from Earth to the moon area. And there are 3 main parts of the Orion. You have the crew module where the astronauts sit and live. You have the service module, which is the back end where the solar panels, and that's built by the European Space Agency. So we have our first international partner in our Artemis program. And then the top part is the launch abort system. And the launch abort system is the part of the rocket that will yank and basically blast off and pull the astronauts in their crew module away from the bigger rocket, the bigger Space Launch System, if there's an emergency on launch and we're afraid there's going to be a failure of the rocket. And so that's our kind of our emergency system to pull our astronauts to safety if we need to. And so Orion is, for the first mission, is already finished. It's sitting at Kennedy Space Center, waited to be connected to the rest of the rocket. And this is our first Orion for Artemis 1. And in Artemis 1, like I said, will launch from Kennedy Space Center. Everything will be assembled in this really big building called the Vehicle Assembly Building. We stack the rocket vertically in the building, so straight up and down vertically in that building, and as we're stacking it, we're attaching it to the mobile launcher. And the mobile launcher allows us to drive the rocket out to the launch pad. And so the rocket only moves at about 1 mile an hour on this mobile launcher, and then we get it all situated and set up on the launch pad. And then after the rocket launches and the spacecraft goes to the moon and then Orion comes back home, we retrieve Orion in the Pacific Ocean. And the team at Kennedy Space Center is responsible for all of the launching and also the recovery of the spacecraft. All right, so Artemis 1 is our first mission, right? And I'm going to kind of walk you through what that first mission will look like. All right. So here we have the Space Launch System sitting on the mobile launcher at Kennedy Space Center. Okay, and there's these different shots are showing you the different buildings and the different facilities at Kennedy. You have the Launch Control Center, where we have our team of engineers and mission planners there telling us when it's ready to fly. You've got the launch pad area, where we fill the tanks with liquid hydrogen and liquid oxygen about 10 minutes before the mission begins. And then here's a look at our launch control team. And they are going to launch that rocket, and the Orion spacecraft is going to go to the moon, spend a couple of weeks around the moon, and then come home. There's our launch director, Charlie Blackwell Thompson. She's the first female launch director at the Kennedy Space Center, so that's really exciting. And she makes the call on whether or not we launch. And she gets all of her team to let her know if we're a go or no go for the different systems of the rocket. So about a few seconds before launch, we fire the 4 main engines, or the 4 RS-25 engines at the bottom of the rocket. And as you notice, it's not going anywhere, right? Those 4 engines are not powerful enough to get the rocket off the ground. But liftoff takes place when the boosters are lit, and those huge solid rocket boosters propel the rocket off the ground and send it towards space. And all that dust, or it looks like smoke, that you see is actually steam, because there's a huge trench, a water trench underneath the rocket that fills with water right before we launch, and that's what controls the vibrations of the rocket. Now, after we're headed to space, about 2.5 to 3 minutes later, we get rid of the boosters. We don't need them anymore. We get rid of the launch abort system. We don't need that anymore. And we're getting rid of extra mass. We don't want a lot of extra mass on our vehicle, because that slows us down, and we're trying to get faster and faster. Once you're in orbit around the Earth, you're traveling at about 17,500 miles an hour. But to get to the moon, we need to exceed that speed, traveling at about 25,000 miles an hour, and that will get us away from Earth's gravity. So we spend the first 50 minutes or so checking out Orion, making sure it's ready, and then we fire that final rocket. It's called the Intercryogenic Propulsion System, or the ICPS, and that pushes the Orion away from Earth's gravitational force, away from our planet, and sends Orion to the moon. And Orion will spend about 2 weeks or so, a little more than 2 weeks, orbiting the moon, testing out all the systems to make sure everything's working properly. And then that next year, we'll have our first mission with astronauts for Artemis 2. And so Artemis 2 will be a crewed mission to orbit the moon and come back. So inside the Orion spacecraft, we'll have 4 astronauts, and they'll test out the systems. They'll test out their suits. They'll do all the different sequences that they would do for a usual mission. And this gives us a chance to have humans inside of the spacecraft before we land astronauts on the moon in 2024 for the Artemis 3 mission. And so remember, Orion gets us to orbit around the moon, but Orion doesn't land on the moon. We need a lander to get our astronauts to the surface. And we are working with several different companies right now on a series of proposals and ideas of different landing systems NASA will use. So the 3 companies selected to come up with ideas and landers for NASA are Dynetics, SpaceX, and the national team, which includes Blue Origin, Lockheed Martin, Northrop Grumman, and Draper. And so one of these 3 will be chosen for the 2024 mission to land on the surface of the moon, and then the other 2 vehicles could be used later on in future missions, but only one will be selected for that first lunar mission for Artemis 3. Now, when we go to the moon, we are not just going to hang out around the South Pole for a little while and then come home. We want to go to stay. We want to have a sustainable presence so that we can have people living on the surface of the moon for months and then eventually years. And that will give us a great place to test out everything we need from Mars. And so in order to have a sustainable presence, to be able to live in and around the moon for long periods of time, NASA has developed the Gateway. And the Gateway is an orbiting spaceship that stays in orbit around the moon permanently, or for as long as we need it. And it allows astronauts to travel to Gateway in the Orion. And then in the Orion, the astronauts can get out to get inside of a habitat that's orbiting. They can get inside of the lander and then go to the surface. And so the Gateway is in process of being developed now. We've got a habitat that Northrop Grumman's working on, and then Maxar is building our propulsion system. And then we are also going to partner with our other international space agencies to grow the Gateway, kind of like we did for the International Space Station. So it won't be as big as the space station. It's going to be very small in comparison, but we've got the Japanese Space Agency, the European Space Agency, the Canadian Space Agency, and Roscosmos, which is the Russian Space Agency, all working together to come up with ideas on how we can collaborate and grow the Gateway so that we can all benefit from it. And the Gateway is going to be really great because it's in a halo orbit around the moon, which allows us all access to all points of the moon. So we can go to the South Pole first, but if we want to go to the North Pole, we can. If we want to go to the equatorial area of the moon, we can. So we'll be able to have access to all points of the moon. And with each of these missions to the surface of the moon, we will stay longer and longer each time. That first mission with Artemis 3, they'll probably be on the surface for several hours, maybe up to 5 or 6 hours at the most. And then our next mission the following year, they'll be on the surface for days, and then we want to go out to months, and then eventually a year. And this, like I said earlier, will allow us to check out our habitats and our spacesuits, and to figure out if we can take the water, ice on the moon, and turn it into water that we can drink, or can we turn it into oxygen that we can breathe, or even rocket fuel using liquid hydrogen and liquid oxygen. So there are so many things we want to test out on the surface of the moon before we'll be ready to send astronauts over 39 million miles to Mars. So Mars is the final destination. That's where we want to go. And there are people maybe watching today that could be part of those Martian or moon missions. And our younger audience members, our students that come and visit the library could be a part of those Mars missions and be the astronauts that set foot on Mars in the late 2030s. But we will not send astronauts on a one-way trip to Mars. We will send them to Mars and only send them to Mars when we know we can bring them back home. So for those of you who are interested in traveling to Mars one day, or imagine standing on the surface of the red planet and looking up at the nighttime sky. That is what Earth looks like. This tiny little blue dot in the sky just shows you how far away you will be from everyone else on Earth that you care about, right? You are going to be 39 million miles away. And so it just shows you how challenging these missions will be in the future, and how NASA is very serious about getting it right and learning everything we can by sending people to the moon first. So when it's time to send someone to Mars, we'll be ready. All right, in closing, before we do question and answer, I want to talk to you about the different types of jobs at NASA. So you may be thinking, hey, that sounds like a really cool place to work, but I don't know if I want to be an astronaut, and I don't know if I want to be a scientist. Well, you know what? That's okay, because there are so many different kinds of jobs at NASA. And here are a few examples. When you come and work at NASA, usually it starts off as an internship program as a college student. You don't have to go that route, but that's the easiest way to do it. And you can come in as an intern and work with the different scientists and engineers and groups at NASA to figure out exactly what part of engineering, or what part of mission planning, or maybe business and law, or maybe being a doctor for the astronauts. I mean, there's so many different things you can do. And we have people that work in mission control that are manage our missions and help astronauts problem solve when something goes wrong. We have people that train astronauts on how to get out of their spacecrafts in the water, how to go to the bathroom in space, how to, take care of someone if they get hurt, and what do you do if there's a fire, so all of those astronaut training type things. And then you have folks that build the spacecrafts and build the launch pads and do computer software design so that the spacecrafts work off of computers. And you have people that design spacesuits and develop food for astronauts, and are geologists that help us understand what to look for when we travel to the moon and Mars. What kinds of rocks and what kinds of things on the ground do we need to look for to help us learn more about our solar system. And then you have the untraditional roles like me. I work in the communication office, and my job is to share NASA's story with the public. And we have people that work on our social media teams, and our graphic designers and video editors that make all of those videos and images that I showed you today. And folks that do virtual reality and design apps for NASA and manage our money. There's just so many different things that you can do. And so if you're interested in working at NASA one day, look into those internships. And all you need to do is Google NASA internships, and it'll take you to the page and kind of walk you through what you need to apply once you're in college. So with that, I would love to answer your questions. And so I'm going to bring Kim with me on camera, and she's going to help ask some of the questions that you have in the YouTube chat and any other questions that were sent in ahead of time. All right, Kim, what's my first question?
Well, I have a question.
Sure.
Why are we just now deciding to go back to the moon after waiting so long since the Apollo missions?
That's a great question. So, and it just went away. Let me see what happened. There we go. All right, there we go. So after the Apollo missions were canceled a lot because of funding, and we, in the government's mind, we accomplished our goal in beating the Russians or the Soviet Union to the moon, which was part of the space race. And then from there, NASA focused our funding, and our funding comes from Congress. And so the focus then was to build a spacecraft that could go to low Earth orbit and eventually build a space station that we could conduct science with. And so that became the focus of NASA for quite a while. And a lot of it has to do with funding. It also has to do with the priorities of the different president administrations. And doing science in low Earth orbit has been the focus for a long time. And then recently, starting in 2004 to 2006, there became an interest in returning to the moon and going on to Mars. And it's been something that NASA's wanted to do for a while, but it didn't become a priority for the U.S. government until about then. And so we've gone through several presidents since then, and different amounts of money that have been given to NASA since then. And now we're kind of at the point where we're getting close. It takes a long time to build the new spacecrafts because the rockets and spacecrafts that we had back then wouldn't work now. Our technology has changed so much that we have to have a whole new system. And so I'm glad that we're here and we're super close. And now it's going to be a priority. So NASA is working now, has great partnerships with other companies and international agencies as well. And we're making great progress. And within a year or so, you'll see that rocket launch. Great question.
We have a question from the chat that asks if they can be an astronaut before they're 18.
No, you can't be an astronaut before you're 18. The reason for that is that the minimum requirement to apply to be an astronaut is you have to have at least a master's degree in a STEM field. So that could be science, engineering, technology, math. And all of our astronauts that apply have at least a master's degree. And a lot of them have even more advanced degrees like a PhD. So one of the younger astronauts I can think of, and I can't ever remember her name, she was in their last pool of astronauts, and she was a scientist that worked in Antarctica. And I think she was 27 or 28 when she applied and was selected. So you still can be young, but you have to have the education, the background, and the skill set that NASA needs. And I don't know of anyone under the age of 18 that has those sort of accomplishments. There might be a random person out there in the world that has, but you have to at least be a legal adult for NASA to consider you to be an astronaut. Great question.
All right, we're getting some more questions
in the
chat. Although Mars is the ultimate goal now, is there an even longer-term plan for the manned exploration of the solar system? What are the future targets?
That's another great question. So, of course, Mars is our ultimate goal right now. And you think about sending our first missions in the late 2030s, maybe early 2040s. And then we would want to be successful in the same ways we plan to be successful with the Artemis missions on the moon. We want to be successful on those missions on Mars before we think about going even further. Mars is about 9 months away, and that's usually the quickest time we can get there, between 7 to 9 months. And you're talking about like going further than that. Our next option would be most likely somewhere in Jupiter, like Europa is a moon of Jupiter that we're definitely interested in. And we're sending a mission called Europa Clipper there, which is a robotic mission. But it would take probably closer, I don't know, to 5 years to get to Europa. And so unless our rocket propulsion changes dramatically, and there are experimental new types of rocket propulsion like ion engines and things like that that could get us there faster, but they're not tried and true systems, and NASA's not going to put astronauts on something until they're incredibly reliable. So Europa is an option. and also Titan, which is a moon of Saturn, which is even farther away. That it has a similar atmosphere as our planet, and we're going to send a mission called Dragonfly and have a glider or an aircraft kind of fly through Dragon, and I think that one's is scheduled for like 2027, and so that's even further away. So you're looking at 6, maybe even 7 years away from Earth. So these missions take time, to develop, and we're not ready to send astronauts on missions that take more than a few years, for sure. It'll be probably not in my lifetime, and I'm almost 40, and so I don't expect to see astronauts on Europa or Titan in my lifetime, but maybe our younger audience members will be alive to see those missions take place.
Great. How complicated is the equipment for extracting oxygen from moon water, and will it be on the first lander?
So probably not on the first lander. As far as I know, I haven't heard that they plan on taking that type of equipment. That equipment is larger, and so it will most likely be sent ahead of time or pre-positioned. And we call that process in situ resource utilization. So if you ever want to look it up and do a little research, if you just in situ is INC. I'll have to find it. I'll put it in the chat in a little while, and I'll send you a few links that you can pass on. But that equipment is fairly large, and we've done tests in the volcanoes of I went blank, for Hawaii. We've sent the equipment out to Hawaii and have tried to do extractions there. And so we know that it's possible, but we want to practice and spend more time giving it a go on the moon, because things are going to be different there, right? There's not an atmosphere. You're dealing with larger amounts of radiation and in more intense temperatures, whether they're cold or hot. So we want to test it there. And as far as I know, it will not be on that first mission. It probably would be later on, and maybe Artemis like 5 or 6. Good question.
Yeah. Here's a quick one. Who chose the name Artemis for the mission?
Yeah, so our administrator, Jim Bridenstine, came up with the name. And so we've been wanting to name it for a long time. And I've heard lots of different names for the rocket and for the missions over the last several years. But it was like a year ago that our administrator, Jim Bridenstine, says, we need a name and we need it now. And they asked him, well, what do you want? And he says, well, let me think about it. And then that evening, he did some research, and the next morning it was Artemis. And so he came up with the name. He has a daughter. He has daughters as well, and was really excited to have a NASA program named after a woman, and a lot of that has to do with the Artemis name being a part of the first female to go to the moon. So I think it's a perfect name. I don't think we could have come up with anything better.
I love that it's also the twin sister of Apollo, the first mission. It just really fits in with all of that.
It does.
I've got one of our viewers who says, I want to be an astronaut, but I still don't understand how to do that.
Okay. Well, I will do my best to kind of walk you through the steps. The first advice I would give you is to never give up, because becoming an astronaut is not easy, and there are lots of people that want to be astronauts. And if you ever hear any of the astronauts talk, or maybe you Google some of their presentations online, many of them will say they applied many, many times before they were selected. So the first thing you have to do is you need to get a college degree in a STEM field. And while you're in middle school and high school, my advice to you is to take as many science and math classes as you can. If you can take advanced classes, take the AP classes. If you can be a part of robotics clubs or space clubs or any kind of science club in the afternoon times of school, do that. And when you get into college, major in something. You don't have to be an engineer. You don't have to be mechanical or electrical or an aerospace engineer, although there are a lot of those at NASA. But you can also study space medicine. You can study microbiology. You can study geology. There's so many different science areas that NASA's interested in. And then apply for an internship at NASA. So be a part of those internships in college, and then that gets you at least in the NASA family, right? And that gets you experience working at NASA. And so you pick an area of science that you're interested in and stick with it and become the best at it that you can. And then when NASA makes that call for astronauts, then you can apply and you have the right qualifications, right? You have the science background, you have the experience, and you just keep applying over and over, and hopefully you'll make it. Many of our astronauts love to camp. They like survival type camping. They like to skydive. They like to scuba dive. They like to fly aircraft. And so they're pretty exceptional individuals. And so those are all good qualifications, because NASA wants to see that these astronauts are calculated risk takers. So they're willing to take risks, but they are very thoughtful and safe about their risks. And those experiences in scuba diving and being a pilot and doing lots of camping and that sort of thing give them a lot of the tools and the backgrounds they need to help them problem solve as astronauts. So that's the best advice I can give. So good luck to you. I hope to see you in the NASA Astronaut Corps one day.
Next question is, we know so much about lunar geology from the Apollo missions. What further research will Artemis do to explore lunar surface composition?
That's a great question. And my answer is going to be very similar to what I've heard our planetary scientists say. So imagine you're an alien race and you're coming to visit the Earth for the first time, and you visit the Amazon basin in South America. And that's the only place you ever visit. You never visit anywhere else on our planet. Does that tell you a lot about our planet? No, it just tells you one part about it, right? We have very cold regions and we have areas that are deserts, and you can learn so much about our planet by visiting different areas and different climates and different land forms, right? And so it's kind of the same on the moon. The moon isn't all the same, and it doesn't give us a history of the moon by just landing in one place. And so by landing in the South Pole, you're getting an area that has water ice, of course, which is important for human missions. It's also helping us understand, like, how did that water even get there, right? You know, what is the volatile cycle of water on a moon? And we can also study the sun, because since there is pretty much zero atmosphere on the moon, the radiation and the radioisotopes of the sun are in the dirt, in the regolith of the moon, and we can study the sun and energy by looking at the surface of the moon and help understand our own planet. Since we know that the moon was once a part of Earth, you know, maybe it will help us understand the origins of the solar system better, and what all happened, and how did a part of our planet break apart and become, you know, a moon. So there's just so many unanswered questions, and our planetary scientists are really excited about exploring a different area, because they hope to get different answers and new data that they didn't get before during the Apollo missions. Great question.
So our next questions are kind of combined.
Okay.
One says, how much do astronauts get paid, and what's the highest paying job in NASA?
So all of our astronauts, along with all of our government employees, their salaries are all online. It's public record, because they're government employees. And so when you come in as an astronaut, you either come in as a civilian or you come in from the military. If you come in as from the military, you get paid based on your military rank, right? So the higher you are in military rank, the more pay you get. If you come in as a civilian, it's based on your experiences. And so I guesstimate that a lot of our astronauts, if they're at the bottom end, they probably come in somewhere between, you know, maybe 70 to 90,000 a year. I mean, you can go online and look it up, you know, to see. And then at the longer they stay at NASA and the more they grow in the government, the higher they get. But I don't think there is a cap on how much a government employee can get paid. And I don't know what that cap is, but it could be, you know, close to 150. Maybe if you're the administrator, you make like 200,000. I don't know. You'd have to look it up and see. But like I said, it's all public record. But what's interesting is after the astronauts work for several years for NASA, many of them retire, and then they make double what they make at NASA by working in the private sector. So people who work in aerospace make a lot more money working for companies like Boeing and Lockheed Martin and SpaceX and Blue Origin and Dynetics and, you know, Jacob Engineering. There's so many aerospace companies. You make more money working in the private sector than you do working as a government employee. But then you can't say that you officially work for NASA, can you? So there's a trade-off.
I personally would rather be able to say I worked for NASA.
Right. Yeah. And see, me, I'm a contractor for NASA. And so technically I don't work for NASA, but I speak on behalf of NASA. So, it's interesting how it works. NASA works really closely with our contractors. And for instance, a lot of our communication folks are contracted out. And I change different companies like every 3 to 5 years. We get new companies, and my job stays the same, but I officially work for someone else. And that's pretty common at NASA. Most of the people that work on NASA, on property, are contractors, and a smaller percentage are actual government employees. So my husband's a government employee, and I'm a contractor.
All right, our next question is, what further Mars missions are planned prior to an Artemis project getting there?
So right now, the next one is our Perseverance mission. And if I am good enough, I can show you what that looks like. Give me a second. I'm going to try to pull it up so you can see what that looks like. All right, there we go. All right, so here's a look at Perseverance. And Perseverance is a rover that's similar to Curiosity, and it launched last week or the week before. I'm kind of getting my weeks all smushed together, and within the last couple of weeks it launched, and it will land on Mars on February 18th, I believe. So it's about, I guess, a 7 or 8 month flight to Mars, and it's about the size of a small SUV. And what's really cool about this particular mission is Perseverance is also bringing along a little helicopter, and this little helicopter called Ingenuity is going to fly on Mars. And we've never had a helicopter or even a glider, any kind of aircraft, fly around on Mars before. So that's pretty cool. And so this is an animated video of how Perseverance will move around. It's going to a crater on Mars and continuing to look for evidence of microbial life and former life or even current life on Mars. And then once it lands, our little Ingenuity helicopter will get its test flight. And this will be what we call a tech demonstration or a technology demonstration, where we test out something that's never been done before. And if it works, like we hope it does, this will give us a really great advantage when we send people. So let's say you have a Mars base on the surface of the planet, and you want to look out and scout out an area that you want your astronauts to visit in a rover, or maybe someone's in trouble and you can't exactly find them, easily. So you have aircraft that can fly around, kind of like a drone, and look for things that are of interest to you. Pretty cool. So after this, we are looking at hopefully sending another mission, although they haven't officially named it, to retrieve samples from Mars. We do not have any Mars rocks from the planet. We have meteors that were a part of Mars at one point, but we don't have any Mars rocks. And so we would send a lander to the surface of Mars and then bring back rocks. But they haven't scheduled a date for that or like a name for the mission yet. Good question. All right, what else you got?
Someone who's curious about whether or not the astronauts for Artemis 2 and 3 have already been chosen.
Oh, I get this question almost every day, and the answer is, if they have, I don't know about it. So Artemis 2 is probably going to be in late 2022, early 2023, and then Artemis 3 would be in 24. They usually announce astronauts and announce their missions a year to a year and a half out, and that's because they don't want what they call training fatigue. So we train astronauts and then we send them to space. We don't want them to keep training and training and training for a mission that keeps, that they keep waiting on. It's hard on psychologically and in helping them prepare and that sort of thing. So they'll probably announce Artemis 2, I would imagine, in the next year or so. Probably maybe even right before the first Artemis mission, the test mission, Artemis 1. And then maybe after a while they'll name those. But if you really are interested in who they might be, you can look them up. You can see who are our active astronauts right now, and who is eligible to fly on a mission like that would most likely be not rookies. So I don't imagine we'll send a bunch of rookies on our first mission. At least most of the crew will be be astronauts that have flown to the space station before, and maybe they'll have maybe 1, maybe 2 new people. But yeah, we'll have to wait and see. I want to know just as bad as everyone else.
Next question is there another Earth in a different solar system?
Yeah, there could be. We know there are Earth-like planets in other solar systems, and we know this by the Kepler telescope and the Kepler missions. That telescope is designed to look out far into space to look for potentially habitable planets that are similar to Earth. So we're looking for solar systems and suns that are similar to our sun and our star, and looking for planets that orbit that sun that are close, not too close to the sun, but not too far away. So we call like the Goldilocks effect. So Earth is in the perfect place in our solar system where it's not too close like Mercury and Venus to make it way too hot, but it's not farther out like Mars and even Jupiter and the other planets to make it cold. So there are planets we know for sure that are out there that are in a similar place like Earth is. But we don't know what's on those planets. All we can guess is the composition of the atmosphere, based on telescopes and what we think the atmosphere is made of, but we have no idea if there's life on them, or if it's or if there's people on it, or if it's habitable. I mean, it's just so far away. We'd have to have technology like Star Wars and Star Trek to be able to visit planets like that, and we're not quite there yet.
All right. Will any of the Artemis landers carry anything like a physical or virtual entertainment library as opposed to mission-related documents?
So, what do you mean, like fun things for them to watch, like videos and stuff? Is that what they're asking?
That's how I read that question, yeah.
Okay, so probably, yeah. So the space station astronauts, they get uploaded videos and movies and things all the time. They're, the big Marvel movies and Star Wars movies, they allow the astronauts on the space station to see them and watch them before we here on Earth get to see them. So there are special entertainment type things that are uploaded to this system and the servers on the space station. And I imagine if you're going to be on the moon for a really long time, that NASA would do the same thing. But most of their entertainment they would load up on a tablet. So the astronauts get a laptop and they get a tablet, and if they want to load books or movies or photos from home, they are free to do that on their own. And if there's something unique that they want to upload, like a big game, like an NBA game or a big Super Bowl game, NASA will they can't necessarily stream it live because that requires an incredible amount of bandwidth and data, but they can send it up as a video after the fact. Great question.
That's cool. I hadn't even thought about that.
Yeah.
Next question is, how many satellites are out there considering that the rovers are sending images straight back to Earth?
Okay, so satellites, around Mars or just satellites in general?
Not sure.
Not sure. Okay, so for Mars, as far as I know, there are just 2 satellites in orbit around Mars, and they're both orbiters that take pictures of Mars, and they can also act as a relay or a satellite relay for the rovers on the surface to send a signal to one of those satellites and then back to Earth. Or the rovers can also just send a message straight to Earth, but they can piggyback up on one of those satellites in orbit around Mars. As far as Earth, man, hundreds and hundreds of satellites. Most of them are communication and global positioning satellites. And data relay satellites, those kinds of things. But there are lots. The United States is not the only country that can launch satellites, right? So there's quite a few. And they're mostly either in low orbit, or your GPS satellites are usually in high orbit, a high polar orbit too. So there's lots of different kinds. And then you got weather satellites too. So if you Google how many satellites or what kinds of satellites were in orbit around the Earth, you're probably going to get a long list of different types of satellites.
Cool. Are the next generation suits for lunar exploration... Let me try that again. Yeah. Are the next generation suits for lunar exploration ready for production, or is there still research being done on that area?
So yes to both. So yes, some of it is already finished, but there is still more to learn. And so I'm going to show you guys a video of our, if it's letting me, of our suits. It's taking forever to get there, but oh, there it is. Okay.
Moonwalkers, working in 1/6 Earth's gravity, will need spacesuits that let them use their hands and feet
Oh, it's not playing.
Walking to
Hold on,
destinations.
give me a second.
And bending and reaching as they explore.
You know, sometimes things just don't want to work the way I want them to. Let's see if I can make it work now. All right, I'm gonna go. Well, goodness. It's a really cool video of all the suits. I don't know why it's not working. Well, I will tell you about it instead. How about that? So if while I'm playing around with it, I'll see if I can get it to work. So we do have quite a few spacesuits that are that we've been playing around with for a while, and to help us kind of determine what kinds of suits we would need for the lunar surface. You're gonna want to be able to move around a lot easier, right? You're gonna need to move your joints and be able to bend down. And the suits that we used in Apollo, the astronauts were falling over all the time. You know, if you ever watch any videos online, they would trip and they would fall all the time. So we do have new spacesuits, and it's called the XEMU, and I wish that I could get it to play. Let's see if it's working now. Oh, here we go. At least I got it up now. Hold on a second. Zoom, presentation. No. I'm not giving up. Give me a second. I'm gonna make this work. It's gonna happen. So if I can't get it to work for some reason, I will continue and put some links up that can be posted in the YouTube chat, so that way that you can check it out. It's pretty cool. We announced them maybe about a year ago or so. Oh, there it is. I think I got it.
Working in 1/6 Earth's gravity will need spacesuits that let them use their hands
Yay!
and feet, walking to destinations and bending and reaching as they explore. For this new type of work, NASA has been testing prototype planetary suits, culminating in a new suit design, the XEMU.
The XEMU is Exploration Extravehicular Activity Mobility Unit. So it is an exploration spacesuit. So it's a spacesuit that you're going to use as we move forward on Gateway missions and on the lunar missions with Artemis. And then we're using all that to test the suits you would want to use to go to Mars in. So eventually you're going to have to be very independent and very confident in your hardware when you go and do a mission that far away from Earth. The new suits, the planetary walking suits we're working on now, we really hope to provide improved mobility and comfort along with reduced injury potential. And really, like I said, provide the best tool to the crew member that we can provide. Then we want to be able to provide them the ability to kneel down and pick up a rock, like they're going to want to do in their geology science that they're working on. We want this to be a very reliable and durable suit so they can use it day after day in a dusty environment and not have to do a lot of maintenance with it while they're needing to do their mission. So there's a lot of those kinds of aspects that go into improving the suit that we're going to provide for the lunar missions.
I hope that answers some of your questions about the suits. So that first one that you saw, the XEMU, NASA will build the first couple of suits that we use for our first missions. And then we're going to start contracting out and working with aerospace companies to continue to build the suits. And so the design might change slightly or it might stay the same, but I imagine it will evolve and improve over time, just like our suits that we currently wear in space on the space station. Great question. And thanks for being patient with me and trying to get that to work.
Sure. Will you have the Hubble Space Telescope focus in on the lunar South Pole to take some nice aerial photos of the astronauts?
So I think the answer to that question is no. The Hubble is made to look out in deep space. I think it might be too close to look at the moon. However, we do have moon satellites in orbit We have other countries that have put lunar satellites in orbit. And so eventually we'll get to the point where we have a network of satellites in orbit around the moon that can help with communication and imagery and that sort of things that are there permanently, kind of like we have around our planet. But I don't know in the timeline exactly when all of that will take place. But I'm pretty confident we're not going to use Hubble, because as far as I understand about Hubble, it's made to look far out into the solar system, and so the moon is too close for that type of telescope. But we do have observatories here on Earth that can take images of the surface of the moon, and we would be able to see the tops of the base, at least, from some of our observatories, although it might be kind of hard with the lunar pole to get those images. But I'll have to do a little research and see, how they plan to do that. The Gateway will be orbiting, so we'll be able to get photos from Gateway, but I don't know what other satellites we plan to launch to be able to get additional aerial footage.
So did COVID-19 impact the Artemis mission, like with schedules or anything else?
Yes, it did. To what extent, we're still kind of figuring that out. We know that there are some delays for sure. So if you can work from home, you're working from home. A lot of our people at NASA aren't required to be in laboratories, and not all of them work with their hands. There's a lot of work that can be done on computers and for planning and that sort of thing. And so a lot of people are working from home. For those who are building and actually manufacturing, they're back for a little while. Everything was shut down, but for the most part, all of that is happening now, and they're just taking lots of precautions to keep people safe. So we know that there were some delays with our rocket and our spacecrafts for the Artemis missions, but we don't really know how much it's going to impact us yet, because some of those delays are still happening, right? And things could still change on whether or not people can continue to manufacture, or if we'll have to stop again, depending on how bad the virus gets, this winter season. So, but yes, there are some impacts, but right now I don't think it's been more than maybe a few months overall, but it could end up being worse later on down the line. We'll have to see.
So one of our viewers is wondering how many planets are in perfect living conditions, and if they will accept an estimate on that.
Oh, wow. I'm glad that you would accept an estimate because I have no idea. My best suggestion, since you're super interested in it, is to check out the Kepler mission websites. It's Kepler. And I am more familiar with a lot of the human spaceflight side of NASA and not as much about the solar system exploration portion. And so I know that there are several hundred, maybe we've reached 1,000, I'm not sure, of planets that have been discovered by Kepler. But I can't tell you how many of those are Earth-like. Maybe on the website they'll have something like that. So check it out. It's Kepler, Kepler, Kepler missions, and it will tell you about those planets and what we've discovered and what we know and what we might think we know about them.
All right, we have several people wondering if you know how hot the sun is.
Well, it depends on what part of the sun. The sun is, of course, much, much hotter in the center than it is on the surface. And the hot spots on the sun, the dark spots, the sunspots on the sun are slightly cooler. Let me look. I'm going to look it up and see if I can give you a range of temperature. And it's Kelvin isn't helpful at all. I'll do Fahrenheit because that's a little difficult to... Okay, so an average temperature on the surface of the sun is close to 10,000 degrees Fahrenheit. So Google says the average surface temperature is 9,941 degrees Fahrenheit. But that's an average temperature. Like I said, there are areas, the brighter spots of the sun are going to be hotter, and the darker spots of the sun are going to be a little cooler. And cooler, like, it's still hot. Still really hot, the cooler spots. But inside of the sun, I know, is in the millions of degrees. It's super hot in the center. Good question.
Our next question is, do the suits have jetpacks, or will they in the future?
So as of right now, the suits do not have jetpacks, or at least for Artemis missions. There is a part of the spacesuit that we use on the space station that had jetpacks that you could add. And it's not like a jetpack like you would think that's actual jets, you know, like a rocket or something. It just pushes out spurts of air. All you need is a tiny bit of force to get you to move while you're orbiting and in microgravity. And so we did have jetpacks. It was called the Manned Maneuvering Unit that we used during the space shuttle missions to help move around. But we don't use those anymore on the space station. And as far as I know, on Moon and Mars, there's no plan to have any sort of jetpack. If the astronauts want to get around quickly, we've got rovers. We'll send huge rovers for them to drive around if they want to maneuver around on the surface faster. Jetpacks are just asking for all kinds of trouble, and it's way more risk than they're worth.
And then the last question I see here is, what planet is like Earth?
So Mars is going to be the closest. Of course, it's smaller than Earth, but it does have an atmosphere. It's a very thin atmosphere made of carbon dioxide, and the temperatures are not as extreme as they are on Venus. Venus is a miserable planet. It's way too hot to have any sort of life, and it's incredibly difficult to land anything on the surface because it melts after several hours. And so Venus is not a place for people. Mercury is more like our moon, where there is no atmosphere. It's very cold in the shade and very hot in the sun. Jupiter and then the rest of the planets are all gas planets, and they're nothing like Earth. So Mars is the closest to us, and scientists are very firm in their beliefs and their theories that Mars once had water, and we know that there are dried up lake beds. And because of the rovers, we've been able to look at the composition of the dirt and tell that there was once water on Mars, but we don't know what happened to it, and we don't know if there was ever any life in that water. And so that's super exciting to study and to try to figure out. As if right now we think we're the only life in our solar system, and it would be amazing to find that there is life, and life can survive in other places in the solar system. That would be really exciting. How about a few more, maybe 2 more questions?
Well, I'm going to go to my list then, because there's nothing left in the chat. So I was curious about Gateway and how many future modules NASA envisions attaching to it and what those might be.
So that's a really great question. And I don't think NASA has an answer for it, because we're waiting to see how we're going to work with our international partners. I've seen all sorts of graphics that have a really big expanded gateway with multiple habitats and multiple laboratories and an airlock and places to dock to. But NASA's not paying for all that, and NASA's not going to build all that on our own. So right now we have a minimal gateway, which includes the power and propulsion element that's being built by Maxar. And then we have the small habitat that's being built by Northrop Grumman. And then we're hoping that our international partners that I showed you on that picture earlier will want to be a part of expanding it and maybe developing an airlock, an additional laboratory space, and that sort of thing. But those aren't for sure plans yet. But if you really want to see concepts of how big it could be, there are pictures out there online, but they're all concepts. Nothing is set in stone.
And then my last question, I noticed on one of the infographics as I was looking at all the stuff on NASA's website, which if our audience is interested in learning a lot more about it, NASA has a fabulous website with tons of great information that I had a lot of fun reading through the other day. But I was intrigued by the idea that you actually moved rocket parts from Alabama to Florida using a barge. Yeah. On the rivers instead of trucks or trains. Why do you do that?
Well, yeah, that's a great question. And we do use trucks and trains to move things. Like the boosters came from Utah, right? And they're built in Salt Lake City area, out at the Northrop Grumman, formerly known as Orbital, formerly known as ATK, area. And so we do move some things on trucks. There's a lot more things that can go wrong on a truck. There's a greater chance of accidents, which there have been before, times where there's been accidents, and you have millions of dollars worth of hardware that are jostled around. And so a barge, since we're in the South and it's all near the Gulf of Mexico, and the parts of the rocket are being built at MAV, which is Michoud facility in New Orleans. It's right there, next to the Gulf, and we can, take them by barge, to Kennedy, and it's a smoother transition. With a lot less vibration and chance of things getting jostled around. But we've had parts of our spaceships fly in really big aircraft called the Guppy. It's a huge aircraft that kind of looks like a big giant fish guppy, and we've used trucks and trains before. But the smoothest ride is going to be a barge.
Well, thank you so much for being with us today, Patricia. I know I've enjoyed it, and it seems like a lot of our audience has enjoyed it as well. So thank you.
You're
welcome. Thank you so much for spending this time with us today.
You're very welcome. And thank you for all of you who were patient for the first 15 minutes as we were getting things worked out. I'm glad that the streaming worked and everything's good. So I'll close with a different video that you haven't seen if you want to watch it. It's about 3.5 to 4 minutes, and it kind of goes through the Artemis program step by step and all the different pieces that we're building and kind of how it's all going to fit together and how it all kind of basically summarizes a lot of the things that we talked about today. But it's a really great video, and it's called How We Go. And then once that's over, the stream will be over, and we again appreciate your time, and good luck to all of you who are interested in becoming astronauts or working at NASA one day. I hope that I'll see you working with me one day. Bye.
Between 1968 and 1972, America launched 9 human missions to the moon, 6 of which successfully touched down, allowing 12 men to walk on the lunar surface. NASA's next chapter of lunar exploration, called Artemis, has the task of not just going to the moon to create a long-term human presence on and around it, but also to prepare for ever more complex human missions to Mars. In short, everything we must be able to do here, we must first do here. So, what will an Artemis mission look like? Everything is designed and tested with our most important element in mind, the astronauts. This is their deep space, human-rated spacecraft called Orion, built in 3 parts. The crew module, where up to 4 astronauts will live and work throughout the flight. The service module, with life support systems for the crew and its own engine and fuel reserves. And a launch abort system, with engines capable of pulling the crew module to safety during launch should anything go wrong. To accomplish the task of launching our crew and heavy payloads, NASA is building the Space Launch System, comprising of a cargo hold, an exploration upper stage, a massive core stage, and 2 extended solid rocket boosters. Altogether, this is the world's most powerful rocket, and it exceeds the legendary Saturn V of the Apollo era in numerous ways. Sitting on the launch pad, the entire rocket, fully fueled, weighs just over 6 million pounds, 5.2 million of which is just the fuel. Once ignited, there is no stopping what comes next. All 4 RS-25 engines and the 2 solid rocket boosters come to life, thundering our crew upwards. 2 minutes after ignition, the solid rocket boosters are spent and released. 8 minutes after launch, the core stage is depleted and separated. The upper stage fires briefly, placing Orion into a parking orbit around the Earth. Here, the crew reconfigure the spacecraft and check systems to confirm everything is ready for deep space travel. With a go from mission control, the crew reignite the exploration upper stage engines to leave Earth entirely. The exact timing of this maneuver is critical to reach a speed that can escape Earth's gravitational pull, but also put Orion on a course that will intersect the moon days later. Once this burn is complete, the upper stage of the SLS is jettisoned and the crew aboard Orion coast for several days toward all that awaits them at the moon. Approaching the moon, we see the fundamental differences between Artemis and Apollo. Instead of requiring Orion to serve as an expendable lunar command module or to carry a constrained lunar lander, the Artemis missions will take advantage of a different approach, pre-staging. Everything needed for lunar missions will be positioned in advance by commercial and international partners. This includes rovers, science experiments, and human-rated systems on the surface. But it also includes a dedicated lunar station in orbit around the moon called Gateway. Here at this station, we can pre-stage a robust lunar lander and establish a strong communications relay. Designed with open standards, the Gateway can be expanded as new missions and partnerships develop, allowing multiple human missions on the moon at the same time and enabling ongoing science to be conducted even between human missions. The Gateway is also capable of adjusting its orbit to allow access to every part of the Moon, something the Apollo missions could not do. But the real key in this approach is placing Gateway in a unique halo orbit to perfect the maneuvers needed for Mars missions. And with the growing list of commercial and international opportunities, Gateway is the ideal hub between Earth and all that lies beyond. Returning to our crew as they approach Gateway, the Orion must match the elliptical orbit of the station in order to successfully dock. Once on board, pre-selected crew members transfer to the lunar lander, while those assigned to Gateway remain on station. The lunar lander system itself is built for 3 unique steps: descending from the halo orbit of Gateway down to a low lunar orbit, descending from low lunar orbit to the surface, and once the lunar mission is complete, launching from the surface of the Moon and ascending all the way back to the orbiting Gateway. Once back aboard the Orion spacecraft and undocked from Gateway, the crew fire their engine once to break out of the halo orbit and once again to sling the spacecraft around the Moon, placing it on a multi-day trajectory back towards Earth. As they near the end of this journey, the service module is released, and the crew module is oriented heat shield first. Entering Earth's atmosphere at 25,000 miles per hour, the friction of air slows Orion considerably, while also subjecting it to temperatures of 5,000 degrees. With the Orion now at just 300 miles per hour, a series of parachutes uniquely tested and produced for this moment deploy, decelerating the craft to just 20 miles per hour for splashdown. With each successful mission, Artemis ushers in the next wave of men and women to explore our Moon and prove that together we are ready to go beyond.